In this video series, we're going to talk about digital events, the artifacts they produce, and how to observe them. Cybersecurity countermeasures are strategies and techniques that are designed to prevent, detect, and respond to a threat to a computer system. They are crucial in protecting systems from unauthorized access, data theft, and other malicious activities that could compromise the integrity, confidentiality, and availability of data that's imperative to your business or computer system. By the end of this video, you will be capable to define both the key concepts in cybersecurity countermeasure domains and the related necessary knowledge to link those concepts to each other. It's important to remember that implementations should be simple, conditional logic, or matching, or before you create detections that are more sophisticated, like model-driven approaches. Sometimes simple is better than complex. Let's dive in. We have to understand how a process is created and the digital artifacts that are related to the process to develop appropriate detection engineering around them. So here at the top is our digital artifact. This is all of the components after a process is created. So let's dive into how a process is created. A user interacts with something, it creates a process, and that process is going to use an image path to find the executionable binary. That executionable binary is going to operate a file, and again, this is tied to our digital artifact. Our user that's using it is also tied to the digital artifact. We've got identity access management, which accounts for our users. That binary is going to execute a code segment, and the process is also going to create a process code segment. So we need to understand on the other side of this, what are the offensive measures that could be taken that could be part of the compromise in an attack? When we talk about process code segments, this is where an offensive model comes in. And that offensive model modifies the process code segment with things like a process injection, exploitation for privilege escalation, exploitation of remote services, or exploitation of the client's execution. But what we can understand is we can create a defensive model and we can have code segment verification. There's lots of ways to come to solve, but this is the defensive model, and we want to be focused on building detections in this particular space right here. I hope you found this useful, and we'll see you again.